Antiderivatives. Integrate. Problem 17. 6 over square root of x times 3x squared minus square root of x all to the second power. Make FOIL method and open the equation 3x squared minus the square root of x. When you finish the FOIL method, the answer of the equation will be 9x to the 4th power plus x minus 6 times square root of x to the 5th power.
A video camera converts the picture into a
Step 3. Distributive property. You must use distributive property. You will make 6 over square root of x times 9x to the 4th power plus x minus 6 times square root of x to the 5th power. And the answer will give you 54x to the 4th power over square root of x plus 6x over square root of x minus 36x to the 5th over square root of x. Step 4. Simplify. Get rid of the square root of x in the denominator. Then you will have the next equation. 54x to the 4th power times x to the negative 1/2 plus 6x times x to the negative 1/2 minus 36x to the 5th over 2 times x to the negative 1/2. And your answer will be 54 times the square root of x to the 7th power plus 6 times the square root of x minus 36x to the 2nd power. Step 5. Integrate. You must add 1 to the exponent in all x's, and in each equation divide all the equation by that number. The answer will be 54x to the 7/2 plus 1 plus 6x to the 1/2 plus 1 minus 36 squared plus 1. Then you need to add that number and divide it by all the equations in each one. So the answer will be 54x to the 9/2 times 2 all over 9 plus 6x to the 3/2 plus 2 all that equation over 3 minus 36x cubed all over 3. The next step is to simplify. So you will divide 54 over 9, 6 over 3, and the total will stay the same. So the antiderivative of the equation will be 12 times a square root of x to the 9th power plus 4 a square root of x cubed minus 12x cubed plus c.
A video camera converts the picture into a television signal.
For problem A, we have to find the change in the period of the pendulum if original length is feet and it has increased 0.5%. So we have to do 4 plus 4 times 0.005, which will be the increment of 0.5%. Now that we have the length when it has increased 0.5%, we have to find change of the period of the pendulum. So we have to make del t so it will be our time 2 minus our time 1, and we will plug in our different lengths. Once we solve the formula, we get 2.22 minus 2.250, and delta t will equal to 0.005 seconds. For letter B, we have to find the percentage of change of the pendulum. To find the percentage of change of the pendulum, we have to subtract T2, which is 2.22, minus T1, which equals to 2.215 divided by T1, 2.215 times 100. And that will give us our percentage of change.
For part C, they ask us to find the approximate percent change in the period. So first, we need to derivate the original function, which is 2 pi times square root of length over gravity. As a result, we find that the derivative of the original function is pi over the square root of length times gravity. Now we need to find dx, which is equal to time 2 minus time 1. Once we find this value, we can continue. So now you need to bring everything together by making a formula, which is f prime of x times dx, and this should give us our approximation. Our formula should look something like pi over the square root of length times gravity and all the previous fraction multiplied by dx, which is 4.02 minus 4, which gives us 0.02. So now we plug in the values of length, which is 4, and the value of gravity, which in feet is 32.2 feet per second, and multiplied by dx, which is 0.02. This should give us the approximation by derivating. In the end, this method gives us as a result 0.0055 seconds. Now we need to change the previous result into a percentage, and we do this by dividing our result, which is 0.0055, and divided by T1, which is 2.215. And as a percentage result, we get 0.248%. Now for part D, we need to find, using the result we got in part C, the approximate error in the pendulum clock in 1 day. So, as we saw during the procedure, the percentage of change is different than the approximate change. And we find this because the approximation is simply an estimate of what the change is, and it's not the 100% correct answer. So the approximate percent is wrong by a small margin, while the actual percent of change is the correct answer we should be looking for. The approximate change is wrong by 0.005 seconds, and by percentage it's wrong by 0.022%. So explaining a little bit more on what we got on part D, here we simply see that the actual percent of change is not equal to the approximate percent of change, and it's similar, but the answer is still not what we're looking for, and the more accurate answer is that given to us by the actual percent of change. And with this we can conclude with our problem Thank you very much, and we hope you learned something new with us today.